recording. All right. So, um, sure everybody now has read the Birkenhelfen and completed the activity A4, which I think was is due before this lecture. So, but in general, this idea of indifference curves and budget constraint lines and all that, you can see is kind of they work on this through the chapter. So it could be an additional reference for you here. As hopefully we're getting into now, we're sort of trying to understand these shapes, and there have been some questions on where the heck do these things come from. And there's this utility function is a way to mathematically quantify the personal preferences of any given consumer, you, me, whoever. So you could go out and you could ask any individual person how they would trade one good for another. So you could say, how much do you really like your electricity? How much do you really like your car? And you can ask them, how much would you be willing to pay to do X or to do Y, and try to compare their answers across a wide range of goods, or ask them directly, would you be willing to trade this good for another good? And through that, you get some data to sort of help you understand effectively the marginal rate of substitution at a wide variety of points. So like, if you happen to own this much, how much would you be willing to trade in order to get a little bit of this other thing? Well, that effectively is quantifying the marginal rate of substitution. And you could use that to then estimate the shapes of these curves. So that is one way that you get these curves. And then once you have the rough shape of these curves, then you can also come up with mathematical formulations to come up with kind of families of these things. You can say that, you know what, I surveyed 1,000 different people, and there were a number of different shapes, but they're really kind of grouped into a few. And we can capture at least all of one large group of those people using a mathematical function like this one. And so this would be the utility, given you have a certain amount of good A and a certain amount of good B, might be equal to the amount of A you have times the amount of B you have, where each of A and B are raised to some exponent. And those exponents would be something that is unique to the individual. And so I might value A just intrinsically more than you do. And so I might have a different utility for every little amount of A that I have. And so my exponent for alpha here might be different than yours. But the general shape of this is going to look kind of like what you see back here. So it captures the general salient features and then can kind of be customized and tailored and fit to the individual. So that's one thing that it can be done with these utility functions. And so you either build these utility functions either through a fit to data, or you just concoct them as kind of a model of expected human behavior. So we would expect that if there's diminishing marginal returns, that you're going to get particular shapes of these utility functions. And so then the question is, in order to make this easier for us to work with as we do the mathematics of it, do we have a surrogate for these utility curves? And we say, well, rather than drawing these like on a whiteboard every time we need them, we can represent them mathematically as something like what you see here. And that mathematical representation captures all of this stuff, because it happens to be that if you were to draw the so-called level sets of this this function here, you would find that every A-B combination that was on the same line would have the same utility. So this utility is trying to quantify how much joy I get out from owning any amount of capital A or capital B. And this line is representing the different combinations, that was a misclick, I apologize, the different ways that I can cluster A and B together to bring me the same joy, they bring me the same utility. So if you were to plug in numbers for A and B at this point in the line, you would get one value of U. But if you were to shift down to some other point in the line and you plug in numbers for A and B, even though the numbers for A and B would be different, the U that you calculate, this formula here would be the same. And that's what puts them on the same indifference curve. And so that's where these curves come from. And so, then we have to ask ourselves, all the indifference curves we've seen so far have had negative slope. they've all started up here and gone down here. We talked about for diminishing marginal utility, they've headed this way, and for accelerating marginal utility, they kind of go like this. But in both cases, they kind of have this downward slope to them, this slope in this, like shown in this red arrow here. So a question we might have is, do they ever have an upward slope? Can we imagine a type of set of commodities that if you were to query someone, that they would have this upward slope? And I guess maybe I would ask, maybe I'll ask the class that. Does anybody have kind of a guess as to, so if you think about what an upward slope means, does anybody either have a guess of when you might get an upward slope to indifference curves, or what the heck, if you could tell me what your thought is of what an upward slope to indifference curve even means? Does anybody have any comments about that? Maybe we'll do this in a breakout. All right, let's do it. Go ahead. I hear a mic.
I was going to say, just to clarify, so if we see any graphs like the two pictures on the screen right now, those would both be considered negative slopes?
Yes. So that although the acceleration of the slopes differs because they start on the left, upper left, and they end in the bottom right, then I would consider them, they're generally negatively sloping. Any point along the indifference curve has a negative slope, and so I'm calling these negatively sloping indifference curves.
Okay, and then another question, sorry if you've already explained this in another class or something.
No, go ahead.
The difference between these two graphs, like if there was, a problem or what it's representing, the difference in the, like where each one starts and ends, because they look almost reversed, what would that indicate usually?
Well, we'll review that here in about 4 slides. Okay. But basically what the one on the left is showing is that if I were to call, let me see if I change this to a pen here. If I were to say that this is how much you have, that the x-axis or the horizontal axis is how much you have of one commodity A, and that commodity, as we're saying, is a good, then generally, the more you have of A, the better you like having A. And the more you have an A, the better you are. And we also think the same thing with B. The more you have a B, the better things are. And for both of these, that's the case. But what's different here is that on the left-hand side, the more you have of A, the relative value of B becomes greater. So in other words, as you get more and more of A, you're willing to get rid of more of A just to get a little bit of B. And so as you get a lot of A, then you don't care about the next unit of A that you get, but you really care about the next unit of B you get. And so getting, here where it's almost horizontal, if I get one more unit of A, I stay basically on the same indifference curve. In other words, my utility didn't change. My life didn't get any better. But if somebody gave me a unit of B, then that shifts me to a whole nother indifference curve. And so that means that getting a unit of B is so much better for me. And so that's what this sort of means here. It's on the flip side of that over here. This is when you've got, so this is diminishing, I'll put DML, diminishing, or DMR, diminishing marginal returns. And over here, this is accelerating marginal returns. And so here, the idea is that if you have a lot of A, so let's say right here, then if I have a lot of A, then I really, really want more of A, because the thing that I have the most of is the thing that I'm really excited about. And so if somebody gives me a little bit of B, it basically doesn't move me off my indifference curve. My joy stays the same. My utility stays the same. But if somebody gives me a unit of A, I jump to a totally new indifference curve. And so on the right-hand side, in the accelerating marginal returns, the thing that you have more of is the thing that if you got a little bit more of, you would get an even greater utility. Whereas on the left, the thing that you have more of, if you start getting just a little bit more of it, you stop caring. Does that make sense?
Yeah, that was actually perfect. Thank you so much.
Great. Any other questions about this negatively sloping? It's negatively sloping because you kind of like, are giving up some to get, in order to stay on the same indifference curve, you have to give up some and gain another. That's kind of gives us this negative slope. But any other general questions about this, the bend of these? And just as a refresher, I call the thing on the left convex, so I'll put vex here, and I call the thing on the right concave, and I put cave here. And you can kind of think which one looks like a cave. Well, this one kind of looks like a cave. I could walk into it. So if I was walking on the horizontal axis, I would go into the cave, whereas the one on the left doesn't really look like a cave. Is there anything else?
I guess I like wrote everything you said, but to simply sum it up, would it be that the one on the left, your utility doesn't significantly change when you move on the graph, but the one on the right, it does, or is it kind of reverse?
Well, the utility can change. It's the conditions under which you change. The one on the left, the only way your utility is going to change much is if you get a little. If you get whatever you don't have a lot.
The other one, okay.
Right, and then the other one, it's the other way around. So the one on the right,
you already like. So
right.
Okay.
Yeah, the one on the right kind of represents something that you would prefer to specialize on. So the one on the left might be like you choosing, I don't know, choosing things to eat. So the one on the left, you're like, once I have a lot of one food, I really need something else. I need diversity. So the one on the left kind of characterizes the way you make decisions about food. The one on the right might make your decisions about your career. You say, once I get good at a particular thing, I'm going to continue to do that thing. I'm not going to invest a whole lot of time in trying to shift my careers. I might, but that's going to be really rare. It's going to be more common for me to continue investing into doing the thing that I've already invested a lot in.
Mm-hmm. Okay, perfect. Thank you.
Okay. All right. So, so something that I might then, so the question I guess I would have here, yes, it was this guy here. When would utility functions look accelerating? When would they look like this? Or would they look like this or look like this? Either one of those. So can we think of a time where the indifference curves are going to be accelerating? So, so maybe let me put you into a quick breakout rooms and just chat about that. Is either come up with an answer for what the heck does an accelerating indifference curve, or what the heck does an upward sloping indifference curve even mean? Or when might we see an accelerating indifference curve? Either, an answer to either one of those would be fine. So I'll kick you into breakout rooms. And we'll only spend a minute or two on this. Let's do that, okay. Okay, so we are all back, I think. I'm just getting my Zoom sort of, there we go. All right. All right, so does anybody have, so the basic question here that I was trying to get us to answer is, we have an upward sloping indifference curve means that I'm sitting here and I have a certain amount of commodity A and commodity B. Someone comes along and they give me more of commodity A, and then they also give me more of commodity B. Now, when they gave me more of commodity A, I was not indifferent. But at the instant they gave me more of commodity B, I then now became indifferent. So that's what an upward sloping indifference curve means, is that if you give me more of both quantities and just the right amounts of more of both quantities, I will feel the same way I did before you gave me anything. When would that happen? Like, just what's the general time? Does anybody have any thoughts about that you've come up with in your breakout rooms?
So our group talked about this question with the context of the activity we turned in yesterday, looking at the Pareto efficient sets on question 2, where it had a good on one axis and a bad on the other. And in that specific case, the Pareto efficient set was sets C and F, I think, but it ended up looking like an upward sloping indifference curve. So that was the example our group talked about.
Gotcha. I like that thinking. Does anybody else have anything else they'd like to add or other thoughts? Did anyone else, and you can put this in the chat, you don't have to speak up on it, think that bads may be involved somehow, but they just couldn't figure out exactly how? Getting some messages here. Okay. We talked about it could be one good and one bad. So that sounds similar to the previous answer, just like on question 2 of activity, of the activity, there was a bad on one axis and a good on the other axis, and the bad is what changed everything. And so that, I think that's the right kind of line of thinking. And so the people have asked about the second question on the, on activity A4 or B4, the current activity that was just due today. And in that one, the reason the Pareto efficient set was the bottom 2 was because a Pareto movements are always, and I see another question here, if you were willing to take some bad, yeah, okay, that's good. Yes, that we'll get to that in a second, but that is that's the right description of an upward sloping, and I'll mention that in a second. But real quick, just because there were a couple of questions in the muddiest points about question 2 on that assignment. The key thing is that a Pareto movement in a space where you have bads will be toward less bad. So if I've put bad on one axis, the upward movement in utility and preference will be down the axis. And so when I put 2 goods on the axes, 2 axes like this, then, which is kind of like what we have here, then Pareto movements will be any way you can move rightward on the horizontal axis and upward on the vertical axis. If you can do both of those things, moving from one bundle to another, you've made a Pareto movement. If you put a bad on one of the axes, then the Pareto movement would be, say, down on the vertical axis if that's bad, and right on the horizontal axis if that's good. And so it just changes where the Pareto improvement directions are, which is why C and F and those answers were the Pareto efficient set, because they were on the kind of the bottom right of that cluster. The so-called Pareto frontier of that cluster was on the bottom right. Whereas in the first problem, where they're both goods, it was the kind of the upper right, because the Pareto improvements were moving both in that upward direction. And we're getting kind of a similar feel for answers here. And I like in the chat this comment that was made about how much bad are you willing to get if you got some good. If you have, so if I go to the kind of the next slide here, in either of these cases where you have a good on one axis and a bad on the other, if we were to then ask somebody what their indifference curves would look like, then what they would find is we would get generally upward sloping indifference curves. They might be concave or convex, so I'll put these little like dashed lines here, but the general trend would be upward sloping. And what that means is that if I were to sit at one bundle, so I currently have this much, and you know, I can try to make this less abstract. So I currently live in a world with this much pollution or something, or I do something that causes this much bad. Let's say, for example, a dishwasher, for example. The noise of a dishwasher. So usually when you go to buy dishwashers, you find out that they have a bunch of features, and one of those features has to do with how loud they are. But another nice thing about a dishwasher might be that, you know, if you get a louder dishwasher, maybe you get an increase in another feature, like it gets a third rack or something like that. So like so you could think like the number of racks you have in your dishwasher is the good axis, but how loud it is on the bad axis. And so the idea here is that if I had a certain dishwasher, which is, you know, a certain amount of how, you know, a certain noise level and a certain number of racks, and somebody says, okay, what I'm going to do is I'm going to give you a dishwasher that has another set of racks. It has a third rack for your silverware, so it's a better dishwasher. And you think, great, I have improved. But what happens is when you install the thing, you find out that it is simultaneously much louder than your old dishwasher. And so you end up here. And so what you've gotten now is a dishwasher that is a bundle of two things. It is better in one thing, but worse in another. It is more bad in one thing and more good in another. So even though you've got an improved dishwasher in one dimension, you've actually got a degraded dishwasher in the other dimension. So overall, you're indifferent. Overall, you say, you know what? I guess this is better in some ways, but it's worse in others. I may as well just keep my old dishwasher, but if I really have to get this new dishwasher, I don't really care, that's fine. I'm indifferent. So an upward sloping indifference curve means that you have taken on good, but it has been at cost of more bad, and you have landed in the same place. So if you have upward sloping indifference curves, that's usually what happens when you're comparing goods and bads together. And so as you add these shapes to them, then they kind of show you your kind of, oh, and there's a good question. I'll get to that question in a second in the chat. So when you add these shapes to these things, it kind of represents how much bad you're willing to tolerate when you're at certain levels of good. So it might be that when you have a whole lot of good, that suddenly you could take on a lot of bad and you would feel pretty indifferent. Or likewise, if you had a lot of bad, you could take on a little bit of good or even a lot of good and still not be indifferent. So like if the air is just poison, it doesn't really matter how nice your car is. But if you have a really, really nice car, then maybe psychologically you can tolerate a little more pollution or something like that. So you can imagine we can bend these curves so that they're convex or concave in order to sort of represent our relative weightings of good versus bad. Now in the chat, there was the question, what do budget constraint lines look on these graphs? That is an excellent question. It is complex to try to think about how to write a budget constraint line when it comes to the bad, because one would think that I can't come up with a price of bad, because as I get more bad, somehow it seems like it's cheaper. It seems like less bad should be more expensive than more bad. And normally when we draw our budget constraint lines, we say, well, we have a price of this commodity, we have a price of this commodity, we figure out how much we could buy for the budget of each one, and then we connect the two of them together. The budget constraint lines would not be able to be drawn for this one. Now I could go into mathematical detail about what a budget constraint line might look like and how it's kind of bent and all that sort of stuff. But the beauty of it is if we just come up with a way to turn the bad into a negative good, then we can actually come back and put budget constraint lines back on this graph. And so when you read, I think it's the next chapter, chapter 2, you will talk about the term abatement versus pollution. So if we put pollution on the bad axis, it becomes really hard for us to answer this question. What does a budget constraint line look like? Because as you get more pollution, it somehow needs to be cheaper. So just mathematically, it's just harder for us to come up with a good framework to put this all on paper. And that's why economists use the term abatement. All abatement means is like negative pollution. So if you have more abatement, that means you have less pollution. But by flipping the axes around so that you can say no abatement means that there's, as much pollution as possible, and a lot of abatement means some of the pollution has been reduced, then now we have a framework on which we can actually start pricing abatement. We can say, how much does it cost for the first ton of abatement, for the second ton of abatement, and so on and so forth. And then we get something that looks a little bit more like a budget constraint line like we're used to. Now, I'm not going to go into too much more detail about this because it turns out that the price of abatement isn't constant. It actually, if you haven't done any abatement, the abatement is cheaper than if you've done a lot of abatement. And so we'll talk a lot more about that in the next chapter and the chapter after that. But in general, whenever you have a good and a bad, you probably want to find a new way to represent the bad as a type of negative good, and then you plot the good on this axis instead of the bad. So that's getting a little funny, but the chapter will go through abatement versus pollution, and I think make it a lot clearer to you. So as you start reading chapter 2, keep that question in mind. Any other questions about this? About this idea about upward sloping have to do with a mixture of bad and good? Just remember, these are the bundles that you would view as indifferent. Regardless of their price, you'd be willing to trade them. And you don't feel like you got any gain from trading them, but you also didn't get any loss from trading them. Okay. All right. All right, so let's move on. So yeah, the indifference here, the upward sloping here, basically would say we can be okay with a little extra bad if we're compensated with extra good, and that's what gives us upward sloping indifference curves. So if you see an upward sloping indifference curve, it's probably between a good and a bad, and that's how we represent it. That's the meaning of an upward sloping indifference curve. We tolerate more of one commodity that we think of as bad because we're getting the other commodity, which we think of as good. Okay. And so a negative slope represents, so that's the good versus good. That's this case right here. And the negative slope represents an acceptable substitution rate. So this is how much I am willing to accept versus a, so that's what we call a positive substitution. So a negative slope is what we refer to as a positive substitution. It's a good for a good. So we get a negative slope, meaning that if I take away a little bit and pick up a little bit more, then I end up in the same place that I was before in terms of the joy that I feel in my life. And so that is a positive substitution, and it happens to have a negative slope. Alternatively, these increasing indifference curves, we refer to those as negative substitutions. A negative substitution means that if you take away this one thing and you give me more of the other thing, I'm now going to be in a bad situation. I'm going to be worse off than I was. And so the indifference curves that correspond to those situations are going to be positively sloped. So a negative substitution is a positive slope. So we mainly will focus on these negative substitution rates. And so these substitution rates, the marginal rate of substitution, that's the slope of the line tangent to these curves at any one of these points. And we say these are negatively sloping, meaning that their marginal rate of substitutions all have the same slope, that these lines right here, regardless of where you draw them on the curve, are all going to be negatively sloped. And that's why we call this negatively sloping. And so the marginal rate of substitution is effectively how much I'm willing to give up of one thing if you give me a little bit of the other thing. And so that's the slope of this line is telling you the exchange rate. When I own this much of good A and this much of good B, then this I'm willing to give up this much of my good B if you give me this much of good A, or vice versa. I'm willing to give up this much of good A if you give me this much of good B. That's going to shift me on my indifference curve, changing the slope of the MRS. And as it changes the slope of the MRS, then my exchange ratio changes. The question, does MRS still apply on good-bad graphs? And yes, it does, but it's interpreted as how much you're willing to tolerate of a particular bad to stay indifferent. So the marginal rate of substitution is like What does it take to stay, what does it take for me to keep you in exactly the same mood that you're in? And then you say, if I were to give you 1 unit of this commodity, if it were bad or good, then the marginal rate of substitution tells you how much of the other commodity would need to change. What changes with the good bad graphs is that the marginal rate of substitution will be negative. So right now, the marginal rate of substitution says, if you give me this much A, here's how much B I'm willing to give you. Now, if we were in a good bad situation, the marginal rate of substitution would be negative, which would be like, if you give me this much A, here's how much B that you would also have to give me in order for me to tolerate that. So it's the negative MRS represents the good bad situation, but otherwise it's still viewed as how much you're willing to trade to stay indifferent, to stay at a certain level of utility. When we see these convex shapes, the thing that we notice is that for any level of one good, the marginal rate of substitution becomes, so for any level of the good on the vertical axis, the marginal rate of substitution starts steep and gets shallow. And so as it gets shallower, the marginal rate of substitution is getting smaller. So that means that I'm getting diminishing returns for the increase that I'm getting in my good A. So the idea is I already have a lot of good B and I don't have much good A. So this steep slope says that I, at this point, really, really value getting some good A. But as you give me good A, let's say you give it to me for free, I move from one indifference curve to another. So you just gave me, I sat at this level of B and you just gave me some A. I now increased my utility. I feel better. I have more A and B. But the amount that you have to give me in order for me to keep feeling better is effectively going to get larger and larger and larger. In other words, the amount of joy that I get from every unit of A decreases as I get more and more and more A. So if I hold B constant, the more A that I get a lot of joy when I have very little A, but when I have a lot of A, I don't get much joy if you just give me more A, the same amount of A. And that's diminishing marginal returns. And that's what these convex shapes look like here. And so that's all we're saying here. So this is just reviewing the stuff that we've talked about so far. Okay. Any questions about this idea that the value is diminishing? Is it becoming more clear as you look at these indifference curves that it's representing things like diminishing value? Excellent questions and comments in the chat so far. It's great to hear the breakout rooms going around too. Okay. All right, so my PowerPoint had frozen there. So the other thing that we talked about so far is the equimarginal principle in consumer, sorry, this is one of consumer choice, which is we have not added prices yet. Oh, I saw a question here. So there's a question. So you want more B to keep the value? So the idea here is that when my indifference curves are negatively sloped, if I get more of any good without giving up any of the others, if you give me more of anything without me giving up anything, I'm going to move to a higher utility curve. So I move to a higher indifference curve. My utility function is going to be higher. So if I'm sitting anywhere on this indifference curve, if you give me more of B or you give me more of A, I will land on a higher indifference curve. That's just how this thing works. What the marginal rate of substitution is about if you give me more of one good, how much of the goods the other good that I already have would I have to give up for the increase you gave me to not make any difference? So it's the idea that I really like cats and dogs. If you give me a lot more cats, how many dogs do I have to give up for me to not notice that you just gave me a lot of the thing that I loved, cats? So it's these two types of the marginal rate of substitution is how much you would give up to compensate for the extra joy that you just received by gaining the other thing. Does that help? Okay. Yeah, it's a little weird, this indifference stuff. It's like, because you just got something. It's in your mental models of things. You're like, I just got something, so I'm doing better off. And like that's the whole point. It's like, all right, so I gave you something. How much are you going to give me to put yourself back in the state that you used to be in before I gave you that? That's what the indifference curve is all about. All right. So we haven't talked about prices at all now. This is just, in a world without prices, how would we trade things? Now, once we add prices, then we can ask the question. Now, prices are interesting because prices mean that we don't directly negotiate on our goods. We just, there is this, that somebody has set a price on the market and we trust that price, and all of our trades are mitigated by this price thing. And so the question then is, given that there's a price out there on the market, then what am I going to choose to do with my inventory of goods? And it turns out that if I want to maximize my utility, then what I should do is I should buy and sell things, at least if things are have diminishing marginal returns. I should buy and sell things until my marginal rate of substitution is equal to the ratio of prices for those two goods out in the market. And so the idea here is that the marginal rate of substitution is how much I personally value B versus A. How much of B am I willing to give up for 1 unit of A? But what the price ratio is how much the market values that same exchange. So the market says this is how much the market is willing to give up of B for 1 unit of A. And if those two things match, then there's no benefit for me buying and selling in the market. I just keep my inventory and I'm happy. If those things mismatch, then that means that there's an opportunity there because the market values something more than I value it and vice versa. So the market might undervalue something that I really value. So what I'm going to do is I'm going to sell the market things that I value less than they do. It'll give me dollars back. And then with those dollars, I'm going to buy the thing that the market values less than me. And that's going to increase my utility. So that's the idea, is I'm using the surplus with respect to the market to change the goods that I own so that I can maximize my utility, capitalizing on the mismatch between the market's preferences and my preferences. And in the end of the day, my preferences are going to be equal to the market's preferences. They will match. And then that's when I know that I'm done buying and selling. Okay. So I'm just opening up the questions app that I've got. All right. Okay. So what does that look like? Well, so if we draw our budget constraint line, the slope of the budget constraint line is basically the price ratio. And so that is how much the market is willing to give up of these things. They all fall along this budget constraint line. And so if I would like to engineer my inventory of these two goods so that my marginal rate of substitution lies right on top of the budget constraint line, because at that point I will be at this highest indifference curve. And so this only applies to diminishing marginal returns. So this is the so-called equimarginal principle. And if we think about how this works, is that if I own anything else, so I can afford any bundle along the budget constraint line. So I can afford this bundle. I can afford a bundle up here. Now, at these bundles, the marginal rate of substitution is going to differ from the slope. So this is going to be very steep. The marginal rate of substitution up here is going to be steeper than the budget constraint line. And that's going to mean that I can sell some of my B and buy some A. And by selling some of my B and buying A, my own bundle will move down the budget constraint line closer and closer to this point here. And by moving down that line, I've actually moved up in my utility. So each one of these movements is going to move me closer and closer to this equimarginal principle point. And it's going to keep moving me higher and higher and higher in utility on higher and higher levels of indifference curves until I reach the highest indifference curve I can reach, which is this one up here, which has this single member, this point of tangency, which is the one member of that indifference curve that I can afford. So when you see that the market values things differently than you can take that opportunity to increase your utility by selling the thing that the market values more than you and buying the thing the market values less than you. And that's how consumer choice works. That's all I'm kind of showing here in an animated way. And that's the equimarginal principle. All right. So before we go on to new stuff, then, then are there questions about this equimarginal principle? Where I want you to be right now is to be somewhere in your head okay with the idea that the best bundle is the bundle where the budget constraint line kisses an indifference curve. And this whole process of the buying and selling, that's just me trying to provide you a narrative that helps justify to yourself without doing the calculus that this is a good point to be at. Once we take that for granted, we can throw away the rationale, we can throw away the narrative. We just can sort of trust that there is a narrative out there. This is how all mathematics works. We build it up in increments. We build a couple of assumptions, we see what the results of those assumptions are, and then if we trust the results of those assumptions, we can forget about everything we needed to build up to that point. So we don't quite exactly remember why this point was so great, but we do remember that once upon a time, and we could look it up, we can justify why this point was good. So then now when we move on in all the other slides, when I throw up budget constraint lines, you'll just immediately know that, yeah, the budget constraint line and the indifference curve, where they just touch, that's where we want to be. And there's a reason for that. And I've seen that reason before. And I might forget that reason after this class, but I trust that if I needed to look it up again, I could find it. So that's where I want you to kind of be moving towards. If you don't quite get all of the buying and selling stuff, you just have to kind of get it right in your head once so that so that your own head can trust this tangency idea. Then after that, you can let go of it and just lean on the tangency idea. That's like all of mathematics right there. So any questions about this, getting to this point where we're okay with this tangent idea? Because now we're going to move on, assuming that we're already okay with this tangent idea. Okay. All right. And we're gradually going to move towards things. We're moving out of PowerPoint slides. I'm going to just start, and the lectures will eventually be me writing on a tablet, and then that tablet will go into the notes. So we're getting there because we're getting a little bit more mathy, but things are still kind of graphical right now. So, so that's why we're just kind of doing these animations here. Now in the chapter that you've read by now, then you've seen that Burke and Helfand use this electricity versus non-electricity. So they create a two good economy, where one good is your electricity and the other is any other good you get from the bundling of all of these aggregation of all these other goods that you could possibly spend your money on. And so they draw indifference curves like we've been talking about. You can see that they're downward sloping. You can see that they're convex. So the assumption here is that electricity has diminishing marginal returns, as does this kind of aggregate bundle, this combination bundle over here. So as you get more of everything else, then you kind of value the next increment of getting more of everything else less. As you get more electricity use, you kind of value the next increment of electricity use a little less. And we can put where you're indifferent on these indifference curves. And then we draw a budget constraint line, like this budget constraint line here. So this thick line is the budget constraint line we're focusing on. And this budget constraint line represents all of the different ways you can allocate your budget between electricity and non-electric goods. And you have to decide to yourself, how much electricity am I going to use, given that I only have a certain amount of money, and some of that money that goes to electricity is going to prevent me from spending money on other things. That's opportunity cost. And so we end up deciding it's the point of tangency with your indifference curves. And so these curvy lines here, here, and here are your indifference curves. These are how much you value these two goods relative to each other. And with the way that they trade off, as you get more of one and its value depletes and all that, then the best that you can do on your budget is this point right here. This will bring you the maximum utility, this much electricity use, and this much left over for other stuff. And so this is at one price. So this is how much the electric company prices electricity. And so what we can do with this framework is then to ask questions like, well, what happens when the electric company raises the price? Well, if you remember, when this budget constraint line ends up connecting to this axis down here, and it connects to this axis where the price of electricity, where you've got your budget, which I'll call Y as your budget, divided by the price of electricity. So this is the, I'll call this E max or something like that. So maybe E MAX, if you can read that. And when I shift to tablet, this will be much more readable. And so this is like the maximum amount of electricity you could ever possibly buy. And that's if you spend all of your budget on electricity and on nothing else, you buy this much. And then likewise, if you spent no money on electricity and bought everything else, you would spend this much. And so we create our budget constraint line by just drawing a line between the two of them. And that's at that price of electricity. So I could call this P0 instead of PE. Now what happens when the electric company increases the price of electricity? Well, that's going to make this denominator get, so I'll maybe circle this so that it's a little easier to see. That's going to make this denominator here get larger. And it's going to make the total amount you could possibly spend on electricity get smaller. And so that's what happens here. As they raise the price of electricity, then this budget constraint line rotates down. And as it rotates down, and so now this reflects that I cannot buy as much electricity. Now I'm not going to spend my whole budget on electricity, but this effect of moving that down has the effect that it is going to affect how much electricity I buy. And so my old electricity amount is going to shift down. Now, what's interesting here comes into what couples via opportunity cost. I'm using less electricity, but I'm actually having to spend more money on this amount of electricity. So even though I'm using less electricity, I still am spending more money on my electric bills. So I've managed to mitigate the increase in price a little bit, but I still have to spend more on electricity. You know, it's not like they just increase the price and I decrease my consumption and I'm back to spending the exact same amount. And that means I have less left over for everything else. And so not only did I decrease my consumption of electricity, I decreased my consumption on everything else. So raising the price of electricity causes you to decrease your consumption on other things. That's the beauty of this indifference framework, is that if we understand how people trade off between different goods, then we can start making predictions about how changing a little thing, like the price of electricity, is not going to just change their electric consumption. It's going to change all of the rest of their consumption patterns. It's going to change how much food they eat. It's going to change how much education that they spend their money on. It's going to change all sorts of other things. And so this allows us to see the way that these systems are connected, all through this indifference curve framework. And that's why we go through the process of building these indifference curves. All right, so are there questions just about this idea, about how I shifted the price and it moved my consumption bundle? I said the consumer moved from this bundle to this bundle. And by doing so, the consumer is not only spending less, or not only using less electricity, but actually spending more on electricity. The consumer is using less of everything else. So do we understand this? Are there questions about this idea of rotating the budget constraint line? Does it make sense that I increased the price of electricity and this moved down because now I can buy less electricity because it's at a higher price? Any questions about this? This is another one of those moments where I want to make sure you really get this, because what we do with this is we try to move to an even simpler mathematical framework that you might be more familiar with if you've taken a micro class, like a demand curve. And we use demand curves without having to justify that demand curves actually work, because the justification for demand curves is this utility function stuff. And the utility function stuff is justified by other things. And so a lot of times when we teach a micro class, we start with demand curves, and then we just tell students, just trust me that these things work. What I'm trying to provide is a texture for you, is a foundation, so that before we jump to demand curves, you at least have some idea that demand curves don't come out of thin air. They come from this, and we're about to see how they come from this. That's why I'm just killing time here to see if you have any questions about, does this make sense? This idea of combining budget constraint lines and indifference curves to see how a change in a price of one thing causes a change throughout a whole bunch of other things. All right. Okay. So what we can do is we can say, all right, let's focus just on electricity for the moment. This curve shows me electricity versus stuff. And what I did is I had two prices, price 0 and price 1. And those two prices led to two different consumption levels, two different amounts. So they led to two different utilities. So price 0 brought the consumer this much utility, and price 1 brought the consumer this much utility. And we also know that price 0 brought the consumer this much electricity. And we know that price 1 brought the consumer this much electricity. So, so one of the things we're used to seeing is that as you change the amount of electricity somebody uses, you change the amount of utility. So we view electricity as a good. And so because we view it as a good, as you use more electricity, you're going to get more out of it. Likewise, if I forced you to use less electricity, I've taken good away from you. So you were getting value out of using the electricity, and by forcing you to move down here, so this drop from this utility function up here to this utility function here, utility curve set here, this indifference curve to this indifference curve represents a drop in utility. That's one way we can plot this. But I would like to involve price in this a little bit here. So what I'm going to do is I just did a little flip there where I said I'm going to take the price here and I'm going to put that on the vertical axis. So I've got price 0 showing up there, and then price 1, I'll put it on a little square. I put it at the little higher price here. And then I'm going to have the amount for price 0 that you used. So price 0, the consumer uses this much electricity. And for price 1, the consumer uses this much electricity. Well, those things I've now plotted here. So this is how much you use for price 0, and this is how much you use for price 1. And so what I can see here is that there is a relationship between the price of electricity and how much is used of electricity. And that can be read directly off the demand curve. You could take a bunch of different prices, so you could rotate a bunch of budget constraint lines. You could just try a bunch of different, okay, what about when it's 1 cent a kilowatt hour, 2 cents a kilowatt hour, 3 cents a kilowatt hour? And so you could keep rotating this budget constraint line, and for each one of those, using the same indifference curves, then you could predict different amounts of electricity usage. And that would trace out this blue line here. And we refer to this blue line, which represents the relationship between price and use, as a demand curve. A demand curve. And the demand function is a function which tells you how to get from price as an input to quantity demanded as an output. So the demand curve is the whole curve, like when you graph it, but a demand function is a mapping between price and quantity. So for each price that I give you, it will tell me how much this consumer will use of that good at that particular price. That's the demand curve, is the graph. Demand function is the relationship from price to quantity. Okay? So price goes in, quantity comes out. Demand function. Now, in order to make this function, we have to assume no other prices change. So this is another one of these ceteris paribus assumptions of economics. So in order for us to draw this demand curve only applies if the price changes of the good that we're focusing on, but no other goods. And so in a world where we can take for granted that the prices of everything else are negligible, they're pretty much just staying roughly constant, then this demand curve tells me the consumption pattern for this one good as you change the price around. Okay. Now, you can then ask, well, when does the curve change? So as the price changes, so if I move the price up and down, then the curve stays the same, but the quantity demanded is going to change with the price. So as the price changes, the quantity demanded changes. Now, we can ask, well, when does the actual curve change? So when does the curve move up? When does the curve move down? And so that changes when your budget constraint changes, for one. You say, well, what causes your budget constraint to change? Well, income or the price of other commodities. The other thing that can change is your indifference curves. So if your utility function changes, so you reach a different point in your life where your preferences change. So if your preferences change, your demand curve will change. If your income changes, your demand curve will change. If the prices of other commodities change, your demand curve will change. But if the price of this commodity changes, the demand curve doesn't change. In fact, it tells you how much you will consume at this new price. So in economics, we often talk about there's changes in demand and changes in quantity demanded. Changes in quantity demanded reflect changes in price, basically. So as price changes, quantity demanded changes. But changes in demand reflect changes in other things, changes in income, changes in the price of other goods, or changes in your preferences. So again, if you keep in the back of your head these indifference curves and budget constraint lines, you automatically know all of the reasons why a demand curve would change. They change if that budget constraint line is rotating around or if the indifference curves are moving. If the budget constraint line is not rotating around because somebody else's prices are changing, and if the indifference curves are staying put, then in that case, the demand curve isn't moving. It's only the price of the good you're focusing on that's moving, which that does cause the budget constraint line to move, but it stays anchored everywhere else. And so it's the demand curve, again, it's a ceteris paribus. Everything else stays the same, but only the price of the good I'm focusing on changes, and that will then move along the demand curve. But the demand curve will change if the other prices change, or if my utility changes, or if my income changes. Are there questions about that, about the difference there? And so in the next slide, we'll talk about, we'll focus on what happens when income changes specifically, and that may also help. All right, so as an example, if we go back to our indifference curve framework, so we're not looking at demand curves, we're thinking about what generates the demand curves. And in our indifference curves, let's say we're focusing on this budget constraint line here. Actually, no, let's focus on the other budget constraint line. So let's focus on this budget constraint line back here. So with this budget at these prices, this is how much electricity I'm going to buy. Now we have to ask ourselves, what happens if I get a bigger income? If I get a bigger income, my budget for all of my goods is probably going to go up. So if I get a bigger income, I'm going to have more to spend on everything. So my budget constraint line is going to move in an upward direction. It's going to be parallel to my old budget constraint line. But I am now going to be able to spend more on electricity and more on other stuff. And so that's what just changed there. And so now my new consumption patterns happen to be up here. Now it just happens to be that as I increased my income for electricity, my electric use hardly changed just because of how my indifference curves are shaped. But I can see that my amount that I spend on other goods did change. So I did increase my income, And even though my income increased, consumption on one thing didn't increase very much, but consumption on the other thing made a major increase. And so we can tell there's going to be two different types of goods. Goods that respond very strongly to changes in income and goods that respond less strongly to changes in income. And that we're kind of starting to see that here. Now, at my new budget constraint and my new amount of income, we can then do the games to ask, well, what happens if we change the price of electricity? And so in the dark blue set of curves up here, these are in the world where I have a higher income. And then they trace out the move from, as you change the price of electricity, you move your consumption patterns from this point to this point. Or the black budget constraint lines, those are for my old income. So for my old income, I started at this consumption, or I started at whatever this consumption level, and I shifted down to this one as the price of electricity changed. So we can see that changes in income lead to totally different demand curves. The demand curve basically represents the set of all of these points grouped together. And if I shift my income, I totally move my budget constraint lines so that as I change the price of electricity, I sweep through a whole different set of points. And those different set of points are going to be a different demand curve. So that's how the demand curve changes with income. If you increase someone's income, their demand will increase. And that will increase maybe their quantity demanded or not. We'll see, there's different goods and different relationships there. But across the board, for most goods, if you increase income, it will increase quantity demanded, but not because you've changed the price, but because you've given people more money, and they often will then spend more on things that they're already spending on. Now, if I zoom in, I can see that for electricity, even though I've increased my income, the actual amount of electricity that I've increased hasn't increased that much. So we can see that there is that the sensitivity to income changes is going to differ across goods. For a good where your demand, the amount that you purchase increases with your income, we call that a normal good. So electricity in this example is kind of a marginally normal good. If you increase income, you do increase the amount of electricity you use, but not that much. You basically spend most of your income on other things. What we're going to see is that there's other types of goods that don't have this property. Other types of goods, as your income increases, you actually spend less on those things. And we'll talk about that here in a second as we close this lecture. But this is important because if we think about developing nations for sustainability, on one hand, for sustainable development, we want people's incomes to be increasing. We want people to have more access to things. We know that with increased income, they will access increased amounts of utility. So for the social welfare of the world, we know that we can increase that kind of net welfare by increasing the income of everyone across the world. But in developing countries, ones where people maybe don't have much income, then they also might have consumption patterns that are severely constrained by their income. And so as we ensure that we're doing things to help increase their income, or policies that we're analyzing, we know will increase their income, what we have to think about in the back of our minds is that their consumption patterns will also increase. And so for normal goods, these are all the goods that as we increase someone's income, we are going to expect them to consume more. So this is a weird trade-off in that on one hand, we want people to be making more because we want people to be doing better. On the other hand, we want consumption to be constrained because we don't want to overconsume. So we have to try to think about that. How do we live in a world where everyone is living at a higher income and yet not live in a world where everyone is consuming way more than they're already consuming? And that's something that we can try to work out using these economic models. All right, so that's kind of a question of food for thought. The other term that I want you to introduce you to before we close here is inferior goods. And so an inferior good has the opposite pattern for a normal good. So here, if you increase your income, then the demand for that inferior good is going to decrease. So I've drawn an inferior good, or borrowed a drawing of an inferior good over here with these indifference curves. So someone's income has increased. So that's what I've drawn here. Their income has increased. And so they used to, but when they were poorer, when they had less income, they spent a lot on this good and, and a moderate amount on this good. But when their income increased, then their indifference curves lead them to a point of tangency here, where they have increased the amount they spend on this good, but amazingly, they spend less on this other good. Now, we have a couple minutes here, so I guess I'll ask the chat, can anyone think of an example of a good that might behave this way? And my hint is, can you think of goods that are going to be used more by low-income individuals than high-income individuals? I see one answer. I'll wait for a couple answers before I make comments. So there's one answer in the chat. Does anybody else have another thought of what's another type of good or service that people would use more at low income than they would at high income? So far, I've seen ramen, one-ply toilet paper, fast food, bus passes. These are excellent. These are exactly the type of answers I'm looking for. So there are goods that are cheap. Public transportation. Yeah, there are things that you can be passionate about as like a poor graduate student, that once you get your first job, then you forget about. And that's, as you get a shift in income, then what you find is that if you can pay payday advances, that's an excellent example of that. Once you get a certain amount of income, there are certain services you leave behind that you just tend to not use as much because you can afford other alternatives. So one-ply toilet paper, for small increases in income, you might increase your one-ply toilet paper consumption, but for large increases, you say, screw that, I am going to start buying the good stuff. I mean, I'm going to be using, quilted, these things that could double as bedspreads for toilet paper because I can afford it. And I will stop using one-ply toilet paper. Bus passes, I will stop riding the bus because now I can afford other means. Maybe I can afford to live closer. Maybe I can afford to buy my own car, et cetera, et cetera. And so those are so-called inferior goods. When an increase in income leads to a decrease in consumption, which we would show as a decrease in the demand curve. The demand curve would get lower. So, the relationship between price and use would change, so that for the same price, we actually use less of it. Okay. All right, so the only other terms that I want us to leave with here is the flip side of that, inverse demand curve. So sometimes I'll give you a quantity, and I'm interested in what price would you be willing to buy of that quantity. So that's the inverse demand. I call it a curve here, I meant to say function. So there's one curve here, but there's two functions. There's a function that gets you from price back down to quantity, but there's also one that gets you from quantity over to price. And that's so-called inverse demand. That's all we're sort of saying here. All right. But I don't want to keep you here for too much longer. We'll go over this in the next lecture, these things like choke price and things like that. So that's something that we're going to start working with in the next lecture, is how to do the math of demand. That's the next lecture, demand curves and the math of demand, and so-called consumer surplus. All right, so with that, let me give you the attendance question, and then I can take any questions there. So attendance question today, I'll put the link here in the chat. It's also up there on the screen. And I guess I'll ask the question, give me the name of a type of good where, I'm just looking for the general name, not an example of these. So where an increase in income leads to a decrease in demand. So what type of good is such that an increase in income leads to a decrease in demand? So an increase in your income leads you to decrease how much you consume of it. That's the attendance exercise. With that, that's all that I will put you through today. If you don't have any questions, you can feel free to take off. If you have questions, I can stick around for a little bit.
Thank you so much.
Mm-hmm.
Thanks so much.
you. This is the only class where people thank me afterwards. I'm hoping that's a good sign for this class or a bad sign for the other.
Thank you, sir.
So any other, okay, everybody said no.